Okay, so today's topic is abstract class and Java interface. I gave 5 in terms of importance scale, meaning this is the most important, the one of the most important, if not the most important topic of Java programming. So we will talk about abstract method and abstract class, and then we'll talk about interface, and then we'll talk about value proposition of using interface. In general, usage of interface is highly recommended rather than just using implementation class. And we'll talk about the concept of interface as type, and then we'll compare interface against class. Someone says no slide. You should actually have a slide. If you don't have a slide, I'll post it as soon as I'm done. I think I have actually posted the updated version. And we'll talk about how we can define an interface and how to implement an interface. And then we'll talk about how you can have multiple interfaces for your class, and then how you can have inheritance relationship among interfaces. And then last topic is how you can rewrite an interface. So, okay, so you don't see the slide? Oh, I'm so sorry. Sorry about that. Yeah, I think I didn't click the button to show my slide. Sorry about that. Okay, so I hope you can see the slide. My fault. Okay, good. All right. I'm on slide 3. Okay, so what is an abstract method and what is an abstract class? So abstract method is a method that does not have any body, meaning it doesn't have any implementation code. Now, in order to create an abstract method, you are going to use abstract modifier. So example is like this. Here, I'm defining abstract method called subabstract method. As you can see, we don't have any implementation of this method. And you also have to say abstract keyword as modifier. So this is how you define an abstract method inside abstract class. So abstract class is a class that contains one or more abstract methods. Now, as you will see in the following slide, you are going to declare your abstract class using abstract keyword. For example, you are going to use abstract keyword on your class. So this is how you define your abstract class called living thing. You got to have at least one or more abstract method in your abstract class. If there is no abstract method declared in your abstract class, then that's a compile error. Now, because abstract class contains abstract method, an abstract method is not something that you can instantiate. Abstract class cannot be instantiated, meaning you cannot create an object instance from abstract class. So if you try to create an abstract class object, meaning if you try to instantiate abstract class like this, that's a compile error. What that means is that you have to have what is called concrete class or implementation class that provides implementation of those abstract methods. Now, the concrete class that implement those abstract methods have to implement all abstract method of the abstract class, meaning you cannot pick and choose only portion of those abstract methods of your abstract class. You have to implement them all. Now, the way you are going to create concrete class from your abstract class is that your concrete class will extend your abstract class. And you will see example of that in the following slide. Someone mentioned you can't hear. Can you hear me okay now? Can people hear me okay? If you can you send me a message? Okay, good. Yeah. We are moving forward with slide 6. Okay. So this is how you are going to declare your abstract class. Here we are declaring living thing abstract class. As I said before, abstract class has to have at least one abstract method. Here we have one abstract method called walk. So again, if you see the difference between abstract method and concrete method, is that concrete method has actual implementation of the method. So breath and eat have actual implementation of the method. Abstract method, on the other hand, does not have any implementation, so they don't have this parenthesis. Okay, so as I said before, in order to create an object instance, you have to have concrete class that extends the abstract class. So how you are going to extend an abstract class? You are going to use extends, just like extending regular class. So here I am creating human concrete class extending living thing abstract class. Now your concrete class human has to implement all abstract methods of abstract class. Here we have only one abstract method, meaning living thing abstract class has only one abstract method called the walk. So here human has to provide actual implementation of walk method. Now you can create an object instance from human concrete class. Now, when to use abstract methods and abstract class, meaning when do you want to have concrete class, or do you want to design your class as an abstract class and then have a companion concrete class? Now these are the situations that you want to design your class in combination of abstract class and concrete class that extends that abstract class. Now as you can tell, as you see, abstract class is a combination of concrete methods and abstract methods. Now the concrete methods are the ones that you still want every subclass to use in the same form, meaning there is no different implementation. However, if you want your subclasses to provide different implementation but something similar role, yeah, so this is the key word, a similar role in different ways, meaning it provides a different implementation but it does the same thing. And this is in fact the concept of polymorphism. So the concrete methods of the abstract class is the same for all subclasses. The implementations are the same. However, if you want to provide different implementation for subclasses of those abstract classes, then that's the time you want to use abstract methods and abstract class as opposed to concrete class only. Now we are going to talk about the concept of polymorphism and why polymorphism is in fact a good thing, good design for object-oriented programming in another presentation and hands-on lab. In fact, I actually removed the slides and hands-on lab exercise regarding polymorphism because without explaining in detail, it actually adds some confusion. So I decided to take out the slides and hands-on lab exercises from this particular presentation and the lab. So if you do not understand the concept of polymorphism, that's fine. Just understand that abstract class provides mechanism, underlying mechanism for enabling polymorphism. So use abstract classes to define broad types of behaviors at the top of object-oriented programming class hierarchy, but use subclasses to provide different implementation details of those abstract methods. So again, if you do not understand what I'm saying on this slide, don't worry about it. Today we are going to focus on more or less on mechanics of how to create abstract methods and abstract class, for the matter as interface as well. Okay, so what is an interface? Yeah, I'm going to address the questions that you guys are asking on this after the presentation. So some of the questions you're asking are in fact will be addressed by the rest of the presentation. So that's the reason I'm postponing the questions. Okay, so we just learned the concept of abstract method and abstract class. Now, what is an interface? Interface, as I said before, is most critical concept that you want to understand. In fact, whenever I interview the people from college, that's the one of the 10 questions I ask include, for example, what is interface and why you want to use interface. Okay, so this is important concept. Slide number 10. So an interface is something very similar to, let's say, abstract class, but in interface, every single method is an abstract method. Okay, so in abstract class, only a portion of the methods are abstract class, while the rest are concrete methods. However, in interface, every single method is an abstract class. Okay, so it actually defines, it is said that it defines signature of some methods without the implementation of the method. Now, because every single method of an interface is an abstract method, you don't have to use abstract modifier for the methods. Now, just like abstract class, you have to provide an implementation class before you create an object instance. Okay, so concrete class must implement the interface, meaning all abstract method, meaning all methods of that interface, need to be implemented by concrete class. Now, in order to declare your interface, you are going to use interface modifier to the class declaration. So let's see an example. Now, so example is, I'm going to show you the example in the following slide. So this is a key aspect of interface. It defines a public way of specifying the behavior of classes without revealing implementation detail. So it defines a contract between client, meaning user of the interface, and the provider of some task. Okay, so we'll talk about this concept in a bit more detail later on. So for now, I want you to just understand that it is a contract between the client, user of interface, and the provider, the implementation class. So this is an example of an interface called the relation. So you're going to use interface keyword, and this is the name of the interface. So as you can see, every single method in interface is an abstract method. Now, because every method is an abstract method, you don't have to specify abstract, even though you can. Syntax-wise, it is allowed. So this is another example of an interface called the operate car. So here we define a set of methods. Again, there is no implementation body. Okay. Now inside interface, you can define some constants. So as you can see, this interface defines what the actual implementation that implements the interface does. it doesn't reveal any implementation detail, okay, to the user of this interface. Okay, so now let's see why interface is important, and these are very, very critical concepts you want to understand. And same reason why we want to use interface, some of those reasons also apply to abstract class and abstract methods. So we have three reasons why we want to use interfaces as opposed to just concrete class. So when you use interface, you are going to use interface and corresponding implementation. So it's always a combination of interfaces and implementation. So the reason why you want to use interfaces as opposed to just concrete class only. So examples we have seen so far is like we just use concrete class only. We haven't really designed our class as a combination of interface and its implementation. Okay, so reason number one. We want to define what a particular thing does without revealing its implementation. Okay, so in order to reveal an object programming interface, meaning functionality of an object without revealing an implementation. So as you can see, it does reveal the functionality of object as a set of methods. However, interface doesn't have any implementation. Okay, so this is in fact concept of encapsulation is because client is going to use only interface. It doesn't need the implementation. So client is shielded from the implementation detail of implementation class because it's just working with interface. Okay, so that is the concept of encapsulation. Okay, now another key aspect is because client only works with interfaces, the implementation class of that interface can change without affecting the user of interface. Okay, so this is very, very important concept. Implementation can change without affecting the caller or user of that interface because user or caller of that interface just work with interface. It doesn't need implementation, at least compile time. Okay, so the caller does not need implementation class at compile time, only interface is needed. Now this allows different groups to work in parallel with only interface defined. What it means is that you could have a group that is working on, let's say if you want to define, let's say, purchase order, the application. So you could define purchase order interface with a set of methods. And then you could have a two group. One group is the one that actually use that interface. So once that interface defined, this first group can just move on, assuming the purchase order interface is providing some functions they need. I mean, they got all the methods they need, so they should be able to work. At the same time, the implementation, second group is the one that actually implement that purchase order interface. They can work independently as long as they defined the interface. So user group and the implementation group of that purchase interface can work in parallel as long as they have agreed on the interface, meaning they agreed these are the set of methods that are defined for that particular interface. Now that is compile time. Now during runtime, object instance gets created from the implementation class and then is going to be associated with interface type. Okay, so again, this is a very important concept, and I'm going to explain this concept using example later on. Okay, so for now, this might be a little bit confusing statement to you, but this is a very, very important concept. Okay, so just keep that in mind, this particular bullet, and we'll come back to this. Reason number 2, if you want to have unrelated classes, meaning they are not related by inheritance, meaning one class is not a child class of another class, they are completely unrelated classes in that sense. Now, if you want these unrelated classes to implement similar methods, meaning if you want these guys to have similar behaviors, and this is a time you can use interface. Example, let's say we have line class and we have my integer class. And line class and my integer class are totally unrelated, meaning line is not a child class or parent class of my integer and vice versa. Now, if you want for some reason to have a similar behavior on these two classes, this is where you can use interface. Okay, for example, you want to provide a comparison behavior. For example, check is greater. Which one is, if this is greater or less than equal. So these are the methods that you want to impose on both of these classes. Okay, it's a comparison method. That's the time you could define an interface that has these three methods, and then you are going to implement those methods for in each of these concrete class. So just to repeat, you can define comparison interface, which has these three abstract methods, and then you're going to have this line and my integer to implement comparison interface. Okay, so this is reason number 2. When you want to have the multiple unrelated classes to implement similar behavior. Reason number 3, to model multiple inheritance. Now, in Java, a class can have only one parent class. However, if you want to provide some multiple behaviors, you can actually have that class to implement multiple interfaces. Okay, so if you want to have a multiple sets of behavior, each set is going to be defined in the form of interface, and then a class can implement those multiple interfaces. Okay, so a class can have multiple interfaces while it can have only one class. So this is multi-inheritance kind of modeling. Okay, so we have learned abstract class and we have learned interface, and only difference between the two seem to be abstract class has some concrete methods while interface has no concrete methods, meaning all methods in interface is an abstract. They are all abstract methods. Okay, so when to use abstract class and when to use interface. Okay, so the reason you want to use abstract method is that there are still some portion of your class that provides common behavior, the same behavior actually, for all subclasses. That's the time you want to use abstract class. Okay, while the portion of the methods you want to have the same name of the method, but subclasses will provide different implementation. So that is for abstract class. However, if you do not have any common behavior for any subclasses, then that's the time you want to define it as an interface. Okay. Okay, so just repeat. All methods of an interface are abstract methods, while some methods of an abstract class are abstract methods. Okay. And in terms of syntax-wise, abstract methods of abstract class must have an abstract modifier, while the methods in interface do not have to have abstract modifier. And that's typically what you see. And an interface can only define constants, while abstract class can have fields. Abstract class can have properties, meaning fields, because you still have concrete methods, and those concrete methods can access those fields defined in an abstract class. Okay, interfaces have no direct inherited relationship with any particular class. They are defined independently. So interface cannot extend a concrete class, for example, or an abstract class. However, as we will see later on, interfaces themselves can